Hello and welcome to the 7 Days of Science Roundup show, your weekly recap of some of the most fascinating recent scientific discoveries. This week, paleontologists discovered that early tetrapods never went through a tadpole-like stage, the first ever nuclear clocks have been created, the mystery interstellar object 3I Atlas is even older than we realized, and more. Starting off the news this week, paleontologists have overturned a long-standing assumption about the evolution of our ancient ancestors. Namely that early tetrapods, the four-legged vertebrates that include our own lineage, went through an amphibian-like tadpole stage as juveniles. The highly simplified story of evolution that many of us have heard is that certain fish evolved into amphibians, and then some amphibians evolved into reptiles and mammals. However, it's much more complicated than that. This new study adds to the complexity of tetrapod evolution as researchers examined several early tetrapod fossils preserved at Mason Creek, a site of extraordinary fossil preservation in Illinois, dating to about 309 million years ago during the Carboniferous period. These early tetrapods belong to a group called the Embolomeres, which as adults would have been some of the top predators of the time, patrolling the Carboniferous rivers and lakes. However, these Mason Creek fossils were of baby Embolomeres. Remarkably, although the traditional view of tetrapod evolution would have us think that these baby tetrapods should look sort of like tadpoles with external gills, the fossils reveal that they did not. This suggests that early tetrapods didn't all undergo a growth history that included a metamorphosis, and instead, this was likely a more derived feature that originated in later tetrapods, near the base of all still living branches of these animals, becoming secondarily lost in the fully terrestrial amniotes. In other paleontology news, the first identified tyrannosaurid to be uncovered in the Canadian province of British Columbia was described this week. A natural mould of a partial tyrannosaurid snout was discovered at a site in the foothills of the Rocky Mountains, and from this mould, researchers were able to create a highly detailed cast of the original bones that created the mould. Thanks to the quality of this cast, it allowed the paleontologists to identify this individual as a juvenile Gorgosaurus libratus, a species well known from fossils found in the neighbouring province of Alberta. Interestingly, they write how the specimen shows very little variation compared to other Gorgosaurus fossils found across Alberta and even down to Montana. So even across the enormous range these tyrannosaurs existed, their anatomy remained quite conserved, suggesting they inhabited relatively consistent paleo environments. Interestingly, compared to the other tyrannosaurids they overlapped in time and space with, Daspletosaurus, there tend to be far more fossils of Gorgosaurus being found to the north of the key Dinosaur Provincial Park site in Alberta, compared to relatively few to the south. On the other hand, more abundant Daspletosaurus remains are generally found to the south of the park. So it may be that these two tyrannosaurids represent a northern and a southern genus across Laramidia, which overlapped in their ranges slightly. A fascinating glimpse into tyrannosaur distribution. In other news, might these butterflies be key to figuring out how to extend human lifespans? Most kinds of tropical butterflies only survive in their adult forms for a few weeks at most, but there's one kind, the genus Heliconius, that is exceptionally long-lived compared to its relatives. This research has documented a record lifespan for this butterfly, with one individual living for 348 days, nearly an entire year. This extraordinary lifespan has previously been linked with the pollen-feeding habits of Heliconius, a unique diet for butterflies, which usually only feed on nectar. The pollen provides the adult butterflies with a source of amino acids, whereas in other species, they must rely on the resources derived from the leaf feeding they did as larvae. To investigate the effects of pollen feeding, the researchers compared the average lifespans of a particular species of Heliconius when they were allowed to feed on pollen versus when they deprived them of pollen, finding that they lived on average for 47 days with no pollen and 63 days with. However, because 47 days is still much longer than the median lifespan of the longest-lived butterfly species that do not consume pollen, they conclude that Heliconius must also have experienced evolutionary changes that allow them to live for longer and slow their aging. And it's not all just down to the pollen feeding. So it provides a valuable new case study for research into long-lived animals. In other news, a study published in Nature has challenged the view that climate change is more likely to affect tropical species than temperate species. Organisms that live in a tropical climate have often been seen to be more vulnerable to the loss of biodiversity that rapid climate change would bring. But this is the next in a number of studies that has suggested temperate species are more vulnerable. Having studied over 5,000 species of plants and animals at nearly 40,000 locations, they found that climate-related local extinctions affected 49% of temperate species, in comparison to 33% of tropical species. Over a 25-year period, maximum temperature increases in temperate regions have been nearly double that in tropical regions. But the study also found that temperate species are, on top of that, more sensitive to warming. These local extinctions don't mean that species as a whole became extinct, but that they became extinct in a certain area. The research also showed that over 70% of species were not moving to cooler climates as the temperatures warmed, further increasing their vulnerability to temperature changes. This research could be vital in helping conservation planning, making sure that groups target species that are the most vulnerable when they need it, and giving us a better picture of how the changing climate is affecting global biodiversity. Returning again to our most recent interstellar visitor next, as there have been a couple of studies published recently looking at the origins of 3I Atlas, the comet that has flown through our solar system over the last several months, as the third object we've seen enter our solar system that's come from outside it. A while ago, we reported that scientists had used the DH ratio to determine that Atlas had a very cold origin, and a paper published in Nature on Monday has also looked at the DH ratio. It also measured a ratio of carbon isotopes, finding evidence from this of the comet's age, suggesting that Atlas could have formed up to 10 to 12 billion years ago, which isn't that much older than the universe itself, and much older than our own sun. Findings by a separate paper used a different telescope. Whilst the last one used the James Webb Space Telescope, this used an instrument on ESO's Very Large Telescope. Both studies are complementary with their findings, both supporting each other's data and building on it to give us a better picture of what Atlas is like, and even more tantalizingly, where it came from. Finally, for the news this week, scientists have revealed that they've built the first working nuclear clocks. These timekeeping machines use lasers to excite the nuclei of atoms, causing them to jump between energy levels, and then determine the precise frequency of light that induces the shift to keep time. This contrasts with atomic clocks, which are already in use but instead rely on the shifting of electrons between energy levels to keep time. Theoretically, nuclear clocks will be far more precise than atomic clocks, due to the difference in energy required, opening up the possibility for all kinds of exciting new research, especially in the hunt for dark matter. Now, two groups of physicists have built the first ever working nuclear clocks, both based on thorium atoms, as this element has unusually stable energy levels. The precise frequency of nuclear transition in thorium was only discovered in 2024, and this exciting discovery paved the way for nuclear clocks to become a reality, which they now have. The stability of these nuclear clocks is not yet as good as the best atomic clocks we currently have, drifting by about 1 second every 3 million years, compared with the atomic clock drift of about 1 second every 40 billion years. However, there are plans to develop the clocks to make them even more reliable, so this is a very exciting time for the field. He's not reacting. It's an excellent pun.
Time. Is it time?
Oh, it's too hot in here. Well, that's it for the news this week. I really hope you enjoyed learning about all that's happened in these last 7 days of science. As I mentioned in our episode on Wednesday, I'd really like to make these compilation roundup videos as much fun as possible, sort of like a video equivalent of a science magazine in some way, maybe with some bonus sections and contributions from viewers. We're up for whatever suggestions you may have, so please do suggest away in the comments below or email us at 7dos.stories@gmail.com. You can follow 7 Days of Science on Instagram, and also be sure to support us on Patreon if you enjoy what we do here. As always, a big thank you to our patrons, including Andrew Kawam, Brain Weevil, Kang Yin, Chippy Chippy Chappa Chappa, Diana Hernandez, Drov Shruyastava, Ethan Wang, Gabriella, Gary Arrington, Giotist, iRage, Uran Zidovic, John French, John Purdy, Joseph Ree, Josh Lambert, Joshua, Corey Peterson, Leland Lampkins, Lena Rose, Lou, Mark Nevin, Mendicant Fryer, Mike Pace, Ragnar Viking, Ralph Balzac, Robert Preprzyka Jr., Robert Thomas, Salvenial, Sammy Petrikis, Steve Bradshaw, Thomas F. Conroy III, Timothy N. Tedrow, Tracy Merrifield, and Troy Schmidt. Thanks for watching, and we'll see you tomorrow.